In this previous tutorial, I was talking about uh, how to prevent the latch-up issue. Also, I was creating a dev cell layout in Cadence virtual platform. Now, in this tutorial, I'm going to discuss about what is guard ring and how to prevent the latch-up issue by using the guard ring, and what is the necessity of guard rings. Okay, so first of all, so first of all, what is guard ring? Actually, uh, mostly guard ring is used in analog layout design. It's basically a large tab that completely enclose a group of device. So you can see here, this is a NMOS device, and a ring is surrounded by it. It completely enclose this device. Also, if you're looking this PMOS device, here also a guard ring isolate this device. By the way, guard ring more effectively isolate the devices from each other, and that also create a low resistance ring or low resistance well or substrate ring. Because in this previous tutorial we will where I was discuss about why the low resistance path is needed to prevent the latch up. Similarly, by using the guard ring, the P plus ring collects the electron and shield the N plus source and drain. That's why it's create a low resistance path. Also, the NOL or N plus guard rings collect holes and that shields the P plus source and drain. Also, the device isolation is uh, really important in analog circuit design, because we all know that in analog circuit are very sophisticated, and those have too much critical signals net, so we have to isolate those devices from each other. Otherwise there might be some noising issue uh, or signal distortion and so on. So guard ring helps us to isolate those devices from each other. Now if I talking about the guard rings layers, the N plus guard ring or NOL guard ring or N tab guard ring, that actually designed into NOL. So it has some layer like NOL layer, contact layer, N implant layer, oxide layer, and metal one layer. As you can see here, for the P plus guard ring or P sub guard ring or P type guard ring, those are similar. It includes the NO. Sorry, it's a typing mistake. Uh, it includes the contact layer, N implant layer, oxide layer, metal one layer. You can see here the N plus or P plus guard ring layout view. So if I create a guard ring, then you can understand it better way. Let's I already created schematic. uh, Here is an NMOS and PMOS. I want to delete it because I want to here I'm going to show you for only single device, but in practically in a project, analog project, there is a too much devices, but for the tutorial purpose I'm going to show you uh, only for one device, single devices. Okay, so let's make it finger 5. So it looks like a big device. So first separate the pins. Okay, so I'm going to create a guard ring for this device. So before creating guard ring, I have to complete this cell layout routing, cell routing. So I have to connect all the poly layer. Then I have to place here. as it is an NMOS device. Then I have to place the pin. There is another pin which is VDD, and I have to place it in metal too. Okay. So my routing is okay. Then I'm going to create a guard ring for this cell. So before create a guard ring, just select all the device and press Shift plus G. As it is an NMOS device, then I have to put the P tab, and it's a rectangular, and layer name, the surrounding layer, I have to make it the VSS because it's an NMOS device, and enclosing is 0 point. It's your choice. Make sure that there will be no DRC issue. This is too much large. So in this way you can place a guard ring, or you can create a guard ring. After that you have to connect all the VSS. So this is the process. Then how to create a guard ring for any analog design or other design. So if I'm going to run the DRC, see, there has no latch up issue, but there has another issue, which is actually the area of the metal. So I have to increase the area of this metal. If I increase the area of the metal, this DRC will be clean. Like just increase the area. 'To increase again because it's 0.02 micrometer. Let's see it's working or not. Yes, it's working. So just increase the area of this metal. See, there is no DRC issue. So in this way you can uh, create a guard ring for your design. Also you can extend this net outside the guard ring, but make sure this not to be a metal one layer, because the guard ring surrounding layer is a metal one layer. So if you want to uh, extend any connection outside the guard ring, you have to choose another layer, not any metal one layer. So this is actually the process. Also there is something that if you want to reduce the area, let's see, here is some DLC. What is that? Because of the metal one spacing. Yes, and this is spacing. What is it? The 0.12 maybe. NIM is not allowed over the PIM, and the oxide is spacing, so I have to maintain the DRC. Don't make it so close. So basically this is the procedure for. So let's run the LVS. It is clean or not. You can see the LVS also clean. So in this way you can use your guarding. So if it is a PMOS device, so just like if it is a PMOS device, sorry, just select this device, shift G, and for PMOS you have to use N tab and change the surrounding net name and apply. You see here, this is for the N tab or annual tab. This is the way. If I share a big project, or is a project that can understand more better, like okay, can understand it. See, this is a differential amplifier. So in this two device are the PMOS device, and these two device are the NMOS device. So after completing the layout, oh, this is the upper part. After completing the whole layout, then I place the guard ring. So this is basically the guard ring. Here the PMOS, so this is the N tab. You can see here the annual and another and others guard ring layer like PIM. Also, after completing the routing, here I place for the P tab, because this all these are the NMOS device. You can see here. If I So that's why we actually place the guard rings after completing the whole layout routing. Then we place the guard rings, so it's okay.